So I've got this new harmonic drive, dual absolute feedback. So on the motor, on the back, the direct drive motor, there's an absolute encoder for current loop and velocity loop, and you could use it for position loop too, and commutation. And then on the motor shaft at the output, this one's 100-to-1 gear ratio. On the output, there's also a absolute encoder. I'm also very happy with my new harmonic drive shirt, so I just wanted to show that off too. So I tuned this motor up with the HDM 8.0. It's a beta 11. We'll update that. But just real quickly, just your basic jogging after setup and tuning. So at the output shaft, if I go 30 RPM, that's 3,000 RPM at the motor. But what I've done is I've done an absolute immediate home on the absolute encoder on the load. And at the power up, I have this set as the 0 position. 0 came down, was around here, but I offset it. Anyways, I'm going to get plus or minus almost 1 rev at the output. And if I power cycle and if I don't rotate the shaft, it's not a multi-turn encoder, so it's a single turn encoder. You're absolute within a single turn. Where am I absolutely at the output? It'll tell you within 1 rev. But there's no multi-turn, and you got to be careful when you're using cables in a robot. You don't want to wind up your cables. But so I put some soft limits and positive and negative soft limits. So I can rotate almost 360 degrees one way and then almost 360 the other way. And if I power up in any position, it'll have the absolute immediate homing for it. So we'll take a look at the homing method in a minute. So just going through the basic setup, it's still a brushless rotary motor. It has a motor, primary, BiSS, and a load, secondary. We can see here the motor feedback has a clock and a data, +5 and ground. And then the load is going to the control connector, clock and data. So the +5 and ground come from the feedback cable, and the control connector has the secondary load feedback. You can see that a little bit in the picture here. I have the feedback wired from the motor shaft, and then I have the feedback from the load. They go to 2 different places here. And here's the wiring diagram. So this cable that I've got here had a brown for +5 and an orange and a blue for ground. So there were 2 grounds. There was no purple wire. The in is on the motor, clock and data, and the out is on the load, the output shaft. There was a clear wire, which was not the frame or the shield. So I had to connect a separate connection to the shield to the frame at the drive. Anyways, looking at the configuration, it's a rotary on the load. It could be used in a passive mode, so you could still close the position loop on the motor shaft. That's a lot of stiffness, and then see where you are at the load. I'm sure you'll be at the load plus or minus 5 counts. 0.1 degree or less is what I was told. There's no backlash, but there's a little torsional deadband in there. So on the motor, 14 bits, 16384, single turn. There's no alignment bits, pure BiSS-C. This is the configuration, should be in servo loop rate. 2.5 megahertz is fine. We're just clocking the data out every 250 microseconds. And then if there's a bolt of lightning, you could ignore a CRC fault. The load feedback, same thing, 14-bit single turn. There's 2 alignment bits, so maybe the resolution on the feedback could be programmed higher. But this is effective bits, so I mean, even if it had 16 bits of motor or load, still it's the effective bits based on signal to noise. And then a gear ratio, motor turns 100 times to 1. That helps set the gain multiplier. If you have a brake or want to come to a controlled stop, and I'm just in a software programmed mode. No more multi-mode output. We need a tertiary feedback output, which we can figure that out if it's needed. And then, of course, looking at the motor data, there's the part number for the feedback, 1414, so dual absolute. I'm going to give it a little extra velocity here because I may want to go this fast, so that's sort of a theoretical limit. And don't limit yourself on the velocity limit. Go ahead and boost that up. So I'm going to look at the tuning here. That's what happens when you program the drive. You've got to clear the fault, but it's gone after that. So let's take a quick peek at the tuning. And for the dual loop, I tuned the current loop, so get about 1 or 2 kilohertz of current loop bandwidth. That was fine. Velocity loop was tuned up for the motor shaft. I set the integral to 0 so we can see what happens as we integrate in the position loop. That's typically what we do in dual loop, but there's a little hunting or hysteresis around that. So we'll take a look at some relative moves here. So I'm going to move the motor from the center back towards one side and then make a move back and forth with this so we can watch the tuning. And so you can see there's a little, after the move is done, there's a little bouncing and a little hysteresis that's going on here based on our gains. This hunting after the move is caused by the dual loop. So what I'm going to do is turn off the integrator in the position loop. And with no integration, you'll get some steady state error, but you'll stop the hunting that's occurring here. So now you see settles into position, plus or minus 5 counts at the load. And we can integrate in the motor shaft to get a little bit more stiffness. And so these are tuning values that I had previously tuned, so I'm just turning them back on. But I find with the harmonic gear with dual absolute that having stiffness in the velocity loop is good. And of course, it's just convenient to measure the position and close the position loop with the load encoder. You can see that the gain multiplier helps multiply the gain. So we have a pretty high PP term, and it multiplies the feed forward so that while it's moving, you get plus or minus a few counts. So following error goes to 0 while you're moving, and then gets to steady state plus or minus a few counts. They said plus or minus 5 counts, but this looks more like plus or minus 2 counts, maybe 1 or 2 counts. There's a little bit of noise on the feedback device, so but we're able to hold position pretty accurately. So I'd say less than 0.1 degree. So 360 divided by 16, 384, plus or minus a couple of counts of noise. You'll also notice that there's a little bit of torsional wind up here while we're moving at constant velocity. It's a little bit random, but it's still within like 5 counts. So even closing the loop on the position seems to be good. So yeah, let's take a look at after the tuning is done. I'm going to go to what I programmed as the absolute 0 position at the output shaft. So got the old Copley logo pointing straight up. when I power cycle or reset the drive with a homing routine, you can see that there's a position of the motor, which we're not really interested in, but the position of the load, it's been zeroed. So I could wake up in any position within, plus or minus 180 degrees or a little bit less, and still get the absolute position with a homing routine. So what I did is I moved to a position I wanted to be zero. This at the bottom here was zero from the feedback device. So I said, all right, let's make the zero up here. That way I can go plus or minus around zero. We could do a wrap too. That's fine. Absolute position within 1 rev. In an absolute position mode, it always takes the shortest distance to get to the zero. So you have to be careful of cable windup if you have something else attached here. But there's a hole in the middle, so as long as you can withstand the rubbing, that should be fine. So what I did is absolute immediate home with wherever it wakes up for the zero, it subtracts 180, 8192, and that's my new zero position, which is straight up here. And then I set some soft limits around that with a decel rate. So I can approach these soft limits at full speed and still not smash into the limit. So yeah. So I'm going to go 6,000 at the motor. So that's full speed. And with the decel rate configured, it'll start to stop so that you stop on the soft limit. So that's a pretty cool feature of keep it within 1 rev. Let's take a quick peek at the brochures for this. This is the new motor. I downloaded the catalog page on it, and you can see one of the features is the cables come out in different configurations. So you can order which way you want the cables to come out the top or out the back. And they're pretty solid metal connectors. I like them. They pop right in. So for the zero backlash, dual absolute. I mean, they also have options with other absolute single turn on the motor on the motor side, not on the load side. So dual absolute's kind of cool for that. There's the ordering number for the dual absolute, and 16,384 counts per rev on the input, on the motors, on the output, which is load side, and on the input, which is motor side. BiSS-C. It says bidirectional, but it's just clock and data. So we can, with the Copley drive. So we're showing can open, BPL, and BEL for EtherCAT. So the single axis drives here, these drives can do dual absolute feedback. These other drives don't have that dual absolute capability. So, okay, thanks for watching.